the distributed load, so you guys need to be familiar with this kind of problem. But I'm going to review that. I treat this as a review for the problem tomorrow.
Before I forget it, are you gonna put up a practice exam for exam 3?
Yes, I can put the solution of the exam 3 I use in spring semester, but I need to tell you it includes chapter 9. Okay, so there are problems that you're not going to, which not going to.
And you have better than the whole.
Yeah, I can put it up. So it's not a problem, but some of the problems is not include. Some of the chapters is not going to be included tomorrow. Okay. So again, we are given this tree view is no by years and moment diagrams. And let's do it. So when we have this kind of problem, the first thing you need to do is to identify what are the forces externally. Clearly, the distributed load are external force. You can combine everything as a single point force located in the middle. Since this the shape of this distributed load is rectangle, so you can assume it's going to be at the middle of the 8-inch. So we have a diagram like this. The first thing we need to do is to draw the free body diagram for the whole system. So some of you guys might ask me, am I going to cover chapter 1, chapter 2, chapter 3 to chapter 6? Yes and no, because all the concepts are related. For instance, over here, to draw the free body diagram for this beam, we are using the concept we learned in chapter 5. So chapter 5 is actually included. How many forces I need to draw at this joint? 2, right? It's going to be let's name this one A, this one B. So I have B1, Bx. How many forces we need to draw? Do we need to draw at point A? 1. So it's going to be an A. So over here, this is distributed load, and when we draw the free body diagram for the whole system, we hope it's going to be a point force over here. So I know this is going to be 8-inch, and the density of the distributed load is 10 pounds per inch. So how much force I'm looking at over here? 80. Where is the 80 pounds going to be located? 4 inches. So those are the information you need to have before you draw your free body diagram. Once you have this free body diagram, you can solve the supporting force at NA at A and B. Before we start solving that, it is clear we only have one force in horizontal axis, which is Bx. So Bx equals to 0. We have Fy, that is going to be NA plus By minus 80 pounds equals to 0. And if I take A as my reference point, the distance between A and B is 14 inches. What is the distance between the 80 pounds and NA? 14 as well. Can everybody visualize that? Because I have 18 over here, and it's 4 inches shorter and 18 inches, so make this part 14. So when we do that, I think it's clear. B1 multiplied by 14 plus 80 multiplied by 14 equals to 0, which yield B1 equals to negative 80 pounds, which means the force over here is downward. Okay, so if you plug this number and back into this equation, you get NA equals 160 pounds. That is how we did for our overall free body diagram. Any questions? This is just a review of chapter 5. Okay. Now, obviously, I would like to separate that into parts so I can get all the diagrams. But I should write down this first. So how many sections? I should divide this in 3. This portion, and this portion. So it's between 0 to 8, 8 to 18, 18 to 32. Does that make sense to everybody? Okay, so let's start. Free body diagram. We don't have any external force apply over here other than the distributed load, but we do have normal force and moment. I'll just draw the shear and moment and ignore the normal force because normal force is horizontal, and clearly horizontal is 0 because it's the only force, so I'm not going to draw that part over here. But it's going to be 10x over here because of density multiplied by inches, and x is in terms of inch. So the total force applied to here is going to be 10 multiplied by x. Where is this force located? In the middle. So when it's in the middle, what's the distance between the left end and the force? X over 2, half of the x. Does that make sense to everybody? This is most critical part in this problem. So make sure you understand what I'm talking about. Question? No? Okay. So let's do y equation. It's going to be negative 10x over here minus b equals to 0, which means b equals to negative 10x. Okay. Moment equation is going to be, again, I'm using the left end as my moment center. So I have 10x multiplied by the moment arm, which is half x. Is this clockwise or counterclockwise? Clockwise. Clockwise. So it's negative. And the other thing is the b is also going to create moment as well, which is negative 10x multiplied by x. Based on the configuration I have over here, it's clockwise. So I need to have another negative sign in front of it. Other than that, is there any other thing I need to add in to this equation? This one. M equals to 0. So in this case, M between 0 to 8 inches, you're going to get 5 x squared. Okay, so far any question? Is that straightforward? Everybody understand what I'm talking about, what I'm doing here? Any part you don't understand?
Why is it minus 10x?
You understand this part? You need
Yeah.
you need to do that step by step. If you haven't done the first part, never do your moment equation. So you get your v equals to this one, and those two terms counts. They're not just symbolically plugged into a free body diagram. When you write down the equation in a moment, those two must be included.
Alright, so that v represents.
Yes. So this is force multiplied by the moment arm and the moment over here. This is fairly important. You need to understand what I'm doing over here. Otherwise, it's very unlikely you can solve for the problem tomorrow. Okay? So. Okay, so let's draw this one first. It's start from x equals to 0 and end at 8 inch. So 8 inches is around here. It's going to be a negative number. So when I have my shear force, what number do I have at 8 inches? Based on this. Negative 80, right? So it's linear. Over here, this is negative 80. For the bending moment, okay, so it starts from 0, and when it's at 8 inches, how much I'm talking about over here? $320. Because you just plug 8 over here, 8 squared is what? 64. 64 multiplied by 5 is going to be 320. So it's going to be around here. Keep in mind, this is a quadratic equation, so don't just put a straight line. It's going to be something like this. Does that make sense to everybody? Everybody understand why I'm drawing those two lines? Okay. Then, since we finished 0 to 8 inches, I will start the drawing for 8 inches to 18 inches. many external forces I need to draw on this free body diagram? Well, of course, I need to draw the force and moment by definition, but other than those two physical properties, how many forces do I need to draw over here? 1, 2, 3. Only, do I have any support between 0 to 18 inches? Right at 18 inches, it doesn't count. So do I have any supports? No. So how many forces I'm talking about over here? Just one. How much is the force? 80 pounds. Where is it located? 8. 4. Just like this one. So I have 80 pounds at 4 inches, and the total length over here is still x. Question? 80 is because the density over here is 10 pounds per inch, and I have 8 inches, so I need to multiply them together. And this is a rectangle, so it must be at the center, which is going to be 4 inches. Yes?
Find the density from 8 to 18.
Yes, though I say I want to have the equation for this part, but I still need to start everything from 0 inches. Okay, every time you do that, you cannot just say you want to cut over here. You can do that, but I wouldn't suggest you do that, because if you just want to say that part, then this is something you're looking at, right? So you have V over here, you have V over here. This is something you're looking at. Personally, I don't suggest that. It's going to be a little bit ugly and difficult to deal with. So just start from here and only calculate the function between 8 and 18. That is something I'll suggest you. Okay. So if you do this, again, we don't worry about x force in this case because we don't have any. But we do have y forces and moment. In this case, I have negative 80 over here. I have negative v over here. Do I have any other force I need to include in this equation? No. So in this case, v is a constant, which is negative 80 between A to 18 inches. So we can draw it over here like this. Does that make sense to everybody? Okay. Now we need to do the moment equation. Still, we want to have that at your left hand side. So I have 80 multiplied by 4 inches. So am I talking about clockwise or counterclockwise moment? Clockwise. So I have a negative sign in front of it. V is negative 80. I don't really know the distance. I only know it's x. And based on the configuration over here, it is also clockwise. So I have a negative sign in front of it. Do I miss anything in this equation? Plus m. Keep in mind, this is something you guys always forget. You don't put your m term in this equation. So eventually, you cannot find how m is going to look like. So be sure you put m over here. So if you do that, you're going to find n equals to 320 plus minus dx. So if you plug this number, remember what I say on Monday, the moment diagram must be continuous. Okay, so it means that at the distance at 8 inches over here, this is negative 320. So if you put 8 over here, this equation must equals to negative 320. If you fail to do that, you're going to destroy your beam right on the spot. Okay, so if you plug 8 over here, how much you're going to get from this equation? Negative 320. They must be the same. Okay, and the n over here is going to be 18 inches. So you can just plug in the number over here. Don't write down the number here. Right? So over here, it should be here. And this is a linear equation, so it's just a straight line, no longer a quadratic equation. Does that make sense to everybody? Now we need to process the third section of the beam, which is between 18 inches to 32 inches. Remark diagram. Always put those two terms in the beginning because chances that you're going to forget that. Okay, and everything before 18 inches remains the same. I have 80 pounds over here. The distance is 4 inch. Other than that, I do have another force, which is NA, included in this provide diagram. NA in this case is 160 pounds, which is at right at 18 inches. So this is the free body diagram I need to deal with. Any question over here? Is that clear? Everybody understand what I'm doing? No? Okay, then we start to write down our equations. How many forces I'm dealing with over here? 3, right? Negative 80. Positive 160. And what? Minus B equals to 0. So B equals to 80 pounds as a constant. So it will jump from negative 80 over here directly to 80 over here. which makes sense, right? Because at 18 inch point, you add 160 pounds force right on the spot, so it will jump from negative 80 to positive 80. So far, everybody with me? Is that clear? Okay. I also need to do the moment equation. The moment equations still start from the left end, which is going to be negative 80 multiplied by 4 inches, and 160 multiplied by 18 inches. In this case, the 160 is going to be positive because it's counterclockwise, right? Then I need to deal with the b over here. B is a constant, and this is going to give me clockwise, so it's going to be minus 80x plus m equals to 0. So you have 4 terms in your moment equation. So you're going to get moment equals to 86x minus 2,560. Okay, so if you plug 18 into this equation, what are you going to find? What are you going to find? Is this going to be the same on this spot, or is going to be shifted? It's going to be the same. So if you are finding there are something different over here, you're doing something wrong. There are some scenarios that it does jump, but in this course I'm not going to give you guys those kind of problems. So if you find after you're doing your calculation they are not on the same spot between sections, between the turn point of sections, you're doing something wrong. Okay, keep that in mind. So when you do this equation and you plug the number as 32 inches, what do you expect? 0. Bending moment diagram start from 0, ends at 0. So you can say you don't really need to have this equation, but I would grade that. You also need to know they are the diagram is continuous. It starts from 0, ends at 0. If you don't have those kind of drawing in your diagrams, you're wrong. Okay. I think this kind of problem is somewhat tedious, but I don't really feel it's not doable. You just need to be careful because each sections, how many equations are you dealing with? 2. The only thing you need to be careful is the moment arc and the V. In the fourth equation, be sure if you include the term of shear force. If you fail to do that, you can never get the correct answer or the correct function in terms of x. That's number 1. Number 2, if you have moment equation other than the moment in this preferred diagram, you also need to consider the moment created by your shear force. The shear force is the equation you get from your force equations in each sections. So be sure you need to include this part in your moment equation and determine whether it's clockwise or counterclockwise accordingly. In most of cases, if you say if you put a positive negative sign in your V, it's always clockwise, which means it's always negative sign in front of it. Does that make sense to everybody? So depending on how many sections you divide your beam, you will need to draw 3x diagrams for individual one. So if you say you divide everything into 4 sections, the 3x diagram you need to deal with is actually 5, because you also need to include the 3x diagram for the whole system and get the external forces and all the supports. So those are the things you need to be careful. But other than that, I think it's straightforward. But for some reason, you guys really don't like this kind of problem because it's really tedious. Okay, it doesn't matter. You can see that I only divide that into 3 sections, and I use a whole lot of spaces on the blackboard. And I get that even though individual equations is not so difficult to solve, but still, it's just tedious. Question? Yes?
What if say all your equations are right, but
Don't worry that
you have a hard time drawing the graph? Can't draw the graph.
Well, I roll sum. If it's x, what is that?
Okay.
It's a line, right?
Right.
If it's second order, this is the problem you're going to have because sometimes you might say, okay, this is.
Yeah. Is that okay?
I'll be gentle. That's all I can promise you. I wouldn't say what I'm going to do because if everybody in this class are doing the same drawing and you're the only exception, giving me something like this, yes, you get points off. But if you're the only one getting something like this and the rest of them mess this part up, I won't take points. Okay, it depends. Okay. I'll be reasonable. Don't worry, I'm not going to say, okay, you forget this part and it's going to be wrong. But you're going to be engineers. Anybody from College of Liberal Arts? I believe not. So all of you guys are going to be engineers. So you do need to know which direction it is. Okay?